Hi everyone, welcome back to another ThinkSphere math video, and I'm Gary. Today, we will explore one of the most important techniques in quadratic function manipulation, which is completing squares. So what is it? What is a function of it? And how can we utilize it? So before delving into the actual technique, we should know that there are three forms of quadratic functions. The first form is the standard form, which is f of x equal to ax squared plus bx equal to plus c. The second form is the vertex form, f of x equal to a times x minus q squared plus p. And the third form is the factor form, f of x equal to a times x minus q times x minus p. So for this vertex form, it can help us to identify the vertex which will be located at QP right away. And this factor form will help us to identify the roots of the function, or the x-intercepts, if you would like to call it, on the graph, which will be locating at Q0 and P0. So completing squares is a technique that can help us to transform a quadratic function from standard form to vertex form. Therefore, we can easily to identify the vertex right away. So it's just simply transforming from this form to this form. So how can we do that? So let's say we have some function like f of x equal to, let's say, 3x squared plus 6x plus 18. Maybe not 18. Let's do 50. So by simply looking at it, there may not be a way to factor it fully. So how should we do that? Let's make this 50 even uglier. Let's say 47. So there's no way to factor this fully by inspection, by grouping, or whatever. It's definitely not a perfect square trinomial. So how can we do that to make it to be in the vertex form? So our first step would be to factor this 3 out from the first two terms. So we would do something like 3, we extract this 3 out from the first two terms, right? Okay. Next, we would like, our ultimate goal is to make this thing right here, this thing in the bracket, a perfect square trinomial, so that we can make it to be something x plus minus something squared. So it resembles vertex form. So how we do that? We can see that this x squared plus 2x, we are missing something here, a constant. We are missing a constant to make it a perfect square trinomial. So what would be this constant? So we actually have an algebraic and very straightforward way to find this constant. So we first use this 2 and divide by 2. So we will get 1. And then we use this number squared. We will get the constant that we are looking for. So that we are actually looking for a positive 1 right here. And this will give us a x plus 1 squared. So the coefficient of the term right here, divide by 2, square it, gives us the constant. So if we do it right here, we have a 3x squared plus 2x, and we want this plus 1 to make it perfect a square trinomial. However, this 1 comes from nowhere. We did not ask for it. It appears like instantaneously, simultaneously. We don't want it. So we will actually do a subtract by 1 behind it, because we don't want this 1. This one appears from nowhere. And this plus 47, we will still leave it there. And now we would actually leave everything inside for the perfect square trinomial. And we would actually multiply this 3 by the negative 1 to make it a negative 3 to put it out of the bracket. and this plus 47 is still plus 47. And we can combine like terms, which is basically combine the two constants right here, which will give us a plus 44. And we'll just write the thing in a bracket as a perfect square trinomial. So we can see that this would be our vertex form, our successfully transformed vertex form, which would help us to visually identify the vertex right away, which would be locating at -1, 44. So this is how we can transform from a standard form to a vertex form. Factor out the leading coefficient from the first two terms, find the constant term that we're needing in order for this thing in the bracket to be a perfect square trinomial, and then subtracting the same constant from this bracket, because that constant comes from nowhere. That constant didn't exist in this original standard form. And then put this extra thing out, combine like terms, and we will obtain this vertex form. I think that's all for completing squares. They all have this general strategies and techniques. If you found this video helpful, please consider like and subscribe. See you next time.